In this video, I'll be solving some questions under linear expansivity. The first question I'm having here, a metal rod of length 100 centimeter is heated through, first thing, a metal rod of length 100 centimeter. It shows that in this case, the original length of the metal rod is taken to be 100 centimeter, right? Then after that, it's heated through 100 degrees C. That's this is actually temperature. That means we have it's heated through 100 degrees Celsius. Calculate the change in length of the rod. Now, this metal rod is already heated in this case. That means we are going to have our change in temperature to be 100 degrees C. That means our change in temperature, which is delta theta, will be equal 100 degrees C. Right? Then we are asked to calculate the change in length of the rod. So, to calculate the change in length, which is delta L now, right? And given that our linear expansion, which is alpha, is taken to be 3 times 10 raised power minus 5, then Kelvin inverse, right? So here I'm going to have it to be, that's actually alpha, which is equal delta L divided by length, original length, multiplied by what? Change in theta, which is change in temperature, right? So here I'm going to have to be my alpha, which is 3 multiplied by 10 raised power minus 5 equals delta L, which is change in length, right, which is the one I'm asked to calculate for, divided by my original length, which is 100 centimeter, but I need to convert to what? To meter. That means I'll be multiplying my centimeter by 10 raised power minus what? 2. So here I'm going to have to be, that's 100, which is 100 times 10 raised power minus 2, right? Then open brackets again, my change in theta, that's change in temperature, which is what? 100 again, right? Degrees C. Celsius. Then here I'm going to my what? I'm going to make my delta L sort of formula so that I will have my delta L to be equal, that's 3 times 10 raised power of what? 10 raised power minus 5, right? Then times this actually 1, right? Because this is 100 times 10 raised power minus 2, right? And 100 times 10 raised power minus 2 is actually 1, right? So this should be 1. Then I'm having multiplied by what? 100. Then I'm having this to be delta L, which is equal 3 times 10 raised power minus 5, right, times 10 raised power 2. Then I have it to be delta L equal 3 times 10 raised power of what? Of minus 3, right? Then this should be in what? In meter, right? But if I want to express it in what? In centimeter, that means I'll be dividing this by what? By 100, right? So here I'm going to have delta L to be equal, that's 0.3 centimeter. So this is in meter and this is what? In centimeter. 5 centimeter. Calculate its expansivity. So in this case, we are asked to calculate for linear expansivity, right? Then given that our length, the first length, a metal rod of length, which is what? 40.00 centimeter, right? Then at 20 degrees C, which is our theta 1 equal 20 degrees Celsius, is heated to a temperature which is theta 2. That's actually 45 degrees Celsius, right? So you can recall alpha equals to L2 minus L1 divided by what? L1 into bracket theta 2 minus theta 1, right? Then here I'm going to have to be alpha equals to L2, which is 40.05 centimeter minus L1. My L1 is actually 40.00 centimeter, right? Then divided by L1, which is what? 40.00 into bracket my theta 1, which is 45 minus 20. Theta 1, the difference of theta 1 and theta 2. So here I'm going to have my alpha to be equal 40.005 minus 40.00. This should give me about, that's actually 0.05. So this is 0.05, then divided by, this is in centimeter, right? Then this multiplied by this, I should have it to be 40.00 centimeter into brackets 45 minus 20. That should give me 25 degree Kelvin or Celsius, right? So in this case, my alpha is going to be 0.05 centimeter, right, divided by 40 multiplied by 25 rather. So here I'm going to have to be that will be 0.0005. If you press it on calculator, you have something like this: 0.0005. That's actually 6.0 times 10 raised to power minus 5 Kelvin inverse. So if you should have the answer to be this. So here the original length of the steel is actually 600 meter long, right? That's the original length L1. What is the daily variation in its length? Daily variation in length means difference in length. So here the statement here actually represents delta L, which is difference in length. So what is the daily variation? We are asked to calculate the daily variation if the night time and daytime temperature are 10 degrees and also 30 degrees Celsius. So here we are going to have our theta 1 to be equals to 10 degrees Celsius and theta 2 to be equals to 35 degrees Celsius respectively. So we are asked to take the alpha, that is the linear expansion of the steel, to be 12.0 times 10 raised to power minus 5 degree Celsius inverse, right? So now that's just it. So first thing we need to do is that we are going to recall alpha equals to delta L divided by what? L1 into brackets theta 2 minus theta 1, right? So that I'm going to have my alpha to be equal, delta L in this case is unknown because I'm asked to calculate for delta L, divided by my L1 is 600 into brackets theta 2 is 35, right? Then minus theta 1, which is what? 10. Right? So the next thing I'm going to do is that my alpha, since my alpha is typically to be 12.0 times 10 raised to power minus 5, which is equals to delta L divided by 600 into bracket 35 minus 10. Right? So that here, if I make my variation in length, so the formula, I'm going to have delta L to be equal, that will be 12.0 times 10 raised to power minus 5, right? Then multiply by 600 multiply by 35 minus 10, that should give me 25, right? Then pressing everything on calculator, I'm going to have delta L to be equal, that's actually I have to be 600 multiplied by 25, then multiply by this should give me, that's 0.18, right? 0.18 meter. And if, let's check the option, do we have it? Okay, you look at this option, they are in centimeter, so we have to convert to they are in centimeter, we have to convert the answer here to meter. Then converting it to meter simply means we are going to multiply this by what? By, that's 100, right? Multiplying this by 100, I'm going to have my delta L, which is 18 centimeter, right? So here let's simply check, the right option is this, which is 18 centimeter. The original length of the brass is actually 2 meter, right? 2 meter long. At a certain temperature, what is the length of a temperature? What is the length for a temperature rise? That is, temperature rise means change in temperature. That's temperature rise, which is delta theta, right? So in this case, we are giving delta theta to be what? To be 100 Kelvin. So here our delta theta is going to be 100 Kelvin. So if the expansivity of the brass alpha is 18 times 10 raised to power minus 6 Kelvin inverse. So a brass rod of 2 meter long at a certain temperature. So now at a certain temperature, the brass length is 2 meter long. Then we are now asked to calculate the new length, right? If the temperature rise is 100 Kelvin. So here I'm going, the new length, that is, the new length is going to be L2. So here we are asked to calculate for what? For L2. So you can simply record that our alpha equals to, that's L2 minus L1 divided by what? L1 multiply by what? Change in what? In length, in temperature, which is change in theta. So here we are going to have to be alpha, which is 18 multiplied by 10 raised to power minus 6 equal L2 is unknown, right? Then minus L1, which is what? 2 meter divided by L1, which is 2 meter multiplied by what? Change in temperature, which is what? 100 Kelvin, right? So here I'm going to go to make everything here the subject. I'm going to have to be L2, right? Then minus 2 meter rather, equal 18 times 10 raised to power minus 6, right? Then multiply by what? 200, right? So here I'm going to have to be what? L2 minus 2 meter equal, this is going to be 18 multiplied by 10 raised to power minus 6, then times 2.0 times 10 raised to power what? Minus, that's 2 rather, 10 raised to power 2. Then I'm going to use this word to multiply this, right? If I use this to multiply this, I'm going to have to what? L2 minus 2 meter, that's equals to, this actually 18 multiplied by 2 is actually 36, right? So I'm going to have to be 36 multiplied by 10 raised to the power minus 6, then plus 2, that will give me 10 raised to the power minus 4, right? So I'm going to have to be 10 raised to the power minus 4. So the next thing is that I'm going to just, bring this to this side, right? So bring this to this side, I'm going to have to be L2, which is equal, that will be 36 times 10 raised to the power minus 4, then I'll have to be what? Plus 2. Then my L2 in this case will be what? 36 times 10 raised to the power minus 6, minus 4 rather, plus 2. That's going to give us something like, that should give us, that's 2.0036 meter, right? This, it should give us something like this, because we can simply express our 36 times 10 raised to the power minus 4 as, that should actually be, that can be 0.0036, right? Then plus 2. Then this is actually 2.0. So we have this to be here. Then I'm going to have to be 2.0036 meter. So this is our new length, L2, right? So if you enjoyed this video, do well to click on the subscription button, and I'm going to solve different questions on linear expansivity, including area and volume expansivities.